It's about how do we get 1,000 engineers or 10,000 engineers to work productively together on one, effectively, like what comes together as one system. It's not about technology really at all. It's about how you develop technology at scale quickly.
This is DevOps Paradox, episode number 230, Simplifying End-to-End Encryption with Smallstep. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson.
Victor, last week I was working on getting a web server set up and did not put in an SSL certificate.
Be ashamed. Go away. It's free. It's free. I don't know why.
Well, it's free if you can expose the web server to the internet, which I didn't want to do, but then I figured out a different way to do it. That's the fast forward through that story that you don't really need to hear. On today's show, we've got Mike Malone on from Smallstep. Mike, how you doing?
I'm doing great.
That cautious story of just setting up a simple web server, even internally on my network, I don't even feel good about doing things open on my internal network anymore. Do you know why? Because I have these stupid IoT devices that I've tried to segregate off into their own network, but some still, because they're hardwired, still end up on the main network. Now what? Mike, you never have that kind of problem, right? Especially being on the West Coast. You don't have any tech issues out on the West Coast.
None, yeah. Everything works out here.
So your background, before we started recording, you remember being a startup, working with AWS when the only services they had were EC2 and S3.
That's right.
When we got EC2 and S3, that's when the world went crazy.
That was the beginning of it, yeah.
That was at a time when we were still discussing how virtual machines in my own data center were evil. And we should never use them because that VMware thingy wants to steal our everything.
See, and that's all I know. I grew up with them. My first startup was Twitter, I guess X now, competitor called Pounce. And yeah, we were on EC2. There was no VPC. We were telnetting to servers. So it was the bad old days, you know. We were figuring out how to deploy software and to do it at scale and to get new releases out quickly. And it was Web 2.0. I was buddies with folks over at Flickr. They were sort of in the process of inventing what we now call DevOps, along with a few other people. John Allspaw was there. He went on to be CTO at Etsy. In a lot of ways, he was like in a prior life, a real engineer, a reliability engineer. So he's bringing some of that philosophy to software engineering and to DevOps. And yeah, that was the beginning of my career. We've come a long ways.
You mean we came a long ways since everybody's in the same building? There is a data center in the basement, and the whole building is enveloped in a single network that is not accessible from outside.
Yeah. Then we tried to recreate that same paradigm virtually, right? That was like the first thing is like, well, this is what I'm used to, is like a building with physical walls and a data center in the basement and people with the laptops upstairs. And now let's move that to the cloud. But like, I want cloud abstractions that are like the building abstraction and the upstairs abstraction, right? That was phase one. That was what? That was like 2000, 12, maybe.
I remember when I was experiencing the same thing in a company I worked at similar time. The first person that started screaming it was something about VPN. Yes, but how do we now, I don't know what, but how do we now have more than one network? How can that happen? The world is going to collide and destroy itself, and we're going to burn.
Yeah, how do we make sure like everyone's gonna have the same IP address? What are we gonna do?
The good old days of managing IP addresses in an Excel spreadsheet.
Right.
But it was safe because it was in that same building that is inaccessible.
Yeah.
Well, until they went on to okay, look, we're going down a really bad rabbit hole. We shouldn't go down because you should have been using DHCP all along, people. So don't use static IP addresses.
Well, IPv6.
Well, see, now you're bringing in just a whole nother... Okay, so let's go down this rabbit hole. This is a different rabbit hole. I just noticed, speaking of AWS, they're going to start charging for IPv4 addresses for usage of them. Now, they've charged for $1 per month for an IP address, which you've seen that with Elastic IP. But now for every hour that IPv4 address is up, you're going to be charged fractions of a penny.
Nobody knows what AWS charges anyway.
Yeah, right.
You just get the bill at the end of the month and you pay it. And if you dare to go through the bill, you will find at least 100,000 items over there. And you're going to give up anyways.
And it'll reliably be like 3% more than last month's bill.
It's almost like the U.S. inflation rate is applied to the AWS bill every month. Different conversation. Let's not get into politics today. So you started out at Pounce for people that are sub 35 years old. You don't even know what that is. And that's okay because it's gone. How long did Pounce even last?
Oh, man. I was there less than a year, maybe 9 months before it was acquired by 6apart. You remember them? TypePad, Movable Type.
All the blog engines that were actually winning at the time, I will put it that way, until this little open source project called WordPress came around.
Matt Mullenweg, disruptor.
So you were at 6apart during the heyday is what it sounds like.
Yeah. There for a little while. Worked on OAuth, OpenID Connect a little bit during those days. Then went and joined a company called Simple Geo. It was a geospatial data services company. This is when mobile apps started taking off. And I was lead architect there. I was building a distributed geospatial database. So that was sort of next step in my career. That was fun. Distributed multi-dimensional databases are fun.
So you have X, Y, Z, and another dimension that you can no longer manage because it's classified by the U.S. government, correct?
Yeah. Well, there's time. And then there's the fifth one is classified, yeah.
Okay.
I was going to say, once you get to 4, you might as well have 30.
Once you get to 5, you might... 4 I understand. Apart from 4 doesn't matter. 5, 6, 30.
Yeah, it's all non-Euclidean geometry to me, so I don't know.
Now, you mentioned OAuth and OpenID there. Was that something you wanted to do, or was that something that got dumped on you because of the job?
Oh, I enjoyed it. It was interesting standards. There were parts of it that were bureaucratic. Once they got sort of pulled into IETF, OAuth did, it got a little less fun and a little more enterprisey. But it was important stuff and it was interesting. So I didn't mind it. I was young. I hadn't done standards work before. I also did OEmbed, which is like, we never went through any standards body for that. That was more of a like getting drunk at 21st Amendment kind of standard. I wanted to do it. And there was a good reason for it. OAuth was, with the Web 2.0 boom, right? All of these social media satellite sites were being created, and there was a proliferation of logins. And then iPhone happened, and there was the password anti-pattern. Things were getting connected. Like you had your social thing connected to your Twitter and your third-party Twitter mobile app. And you didn't want to be giving all of these third parties your Twitter password. So how do you solve that? You need some sort of delegated authorization framework, one that works on the web. So it was a cool problem. It was fun to solve, and now it's a big thing, which is really cool.
We've seen variations of that sort of step away from even the passwords to where, hey, give me your email address. We'll send you a one-time code to log in. And that's it. So they actually don't even have any passwords.
Yeah.
And that to me is, I like it, but there's still something down deep on the inside that's going, something's wrong with this.
Yeah. It's interesting, right? From like a security perspective, it kind of makes sense because if you're going to have a password reset flow at all, that might as well, like speaking purely from a security perspective, having any other way of authenticating is weakening your security, not strengthening it, right? Because like you can log in with if you have access to the email address, you can log in one way or the other. You can't strengthen it by adding another way to authenticate. From a usability perspective, it's a little bit dubious. I don't like having to deal with that. I use Safari on my phone, and then I use Gmail, and then when I click the link, it opens in Chrome, and I'm sure I can configure it to do something different, but like I've never bothered. And yeah, it's interesting to see that.
It's tedious only because we have LastPass and similar solutions today, right? But if I would have to type my password for every single service I use, that cannot be less tedious than just getting an email and clicking a link.
Yeah, fair enough. Well, in passkeys, man, thanks Apple, I guess. I think it was Apple who came up with that terminology. And so we don't have to explain FIDO U2F and WebAuthn to people anymore. But like, I think passkeys that's the future.
As more of the password managers, Victor, you said LastPass, they're persona non grata right now. But we'll say 1Password, we'll say Bitwarden, and there's a couple of others that are, how shall I say, preferred, if you will, without throwing LastPass under the bus anymore. Once those add in support for passkeys, do passwords even exist anymore? Does that kind of thing even matter?
Shouldn't. I mean, I really hate the whole idea that there is something like LastPass or any other similar solution. To me, that sounds very, 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 very silly. But until everybody else implements something like Google authentication or whatever you're using, I'm not going back to typing passwords. I mean, I'm not going back to having Post-its on my wall and typing passwords.
But it was so easy to rotate those. You just took one sticky off and moved it over to the left. You rotated it, right?
There's truth to that, right? Like, I wish I could remember the paper. I read some academic paper years ago about different authentication mechanisms and why passwords were still around. And in typical like academic fashion, they put together like this matrix of like 30 different authentication techniques and like 25 different important factors. And what they found was the reason people use passwords is because they actually ticked more boxes than any other technology actually did. Like basically the summary was Winston Churchill on democracy, like passwords are the worst form of authentication except for all the others.
It's the best worst solution.
Yeah.
My favorite is, when a site or service forces you to not use the password you can remember, but only the one that is auto-generated or has 57 different signs. Anyways, to use the password that no human being can ever memorize. So that you're really left only with two options, Post-it or a screenshot in Google Drive.
But you can never print it out because then the printer would know that password. At some point, somewhere in the memory of the printer, it would have that password. So you have to get rid of the printer.
Because now they have artificial intelligence. They can figure it out.
That's right. Yeah. ChatGPT knows your password.
Exactly.
Almost definitely. Yeah.
So when you were at 6 Apart, you were dealing with these authentication issues. I'm assuming you were probably still in AWS. Were you doing your own data centers at that point? What was that like?
6 Apart did have their own data centers. I wasn't involved in that there as much. They had it pretty ticked and tied. It was an interesting company. It was fun to work there. They were a Perl shop. Remember Perl?
Painfully,
And,
yes.
Why are you bringing it up?
Yeah,
I
right.
mean, come on. I spent significant amount of time trying to forget it, and now you bring it up.
Yeah,
I hate you.
yeah. Well, luckily, I was off in a corner writing Python, so I was safe from the Perl monster. But yeah, it was an older company. Brad Fitzpatrick did a lot of their core infrastructure. You know that guy? He wrote Memcached. He's at Tailscale now. Six Apart was cool because it was the coolest Perl shop in the world. So like it was still Perl, but they had the 20 best Perl programmers in the world working there, and they were smart people. So it was fun. And yeah, I worked in this little corner. I worked on a pod with a student named David Ricordan who ran the OpenID Foundation. And, that's how I got looped into OpenID Connect and all of that stuff. OAuth and OpenID were funny because like they were sort of competing, but also solving different problems. And that's still confusing to people. And now they're merged, which just makes it even more confusing with OAuth plus OIDC. Because yeah, for the first like 5 years, everyone involved was trying to explain to everybody why they were different things, and now they're not.
So basically, they were two standards that merged to form a third.
There's still two standards. OAuth is all right. All right, you really want me to
Go for it.
OAuth is authorization, right?
Yes.
OAuth is actually two things. There are the OAuth flows, which are like the 2 or 3-legged flows where you prove who you are to some like identity provider. I think they use a different word. They use like relying parties and blah, blah, blah. But whatever, you prove who you are to Google. And then there's a third party that is getting access to some resource that is your resource that Google is hosting, for example, or Twitter or whatever, right? But OAuth was always designed as an authorization protocol. So like semantically, the OAuth token is this like opaque bearer token, and it doesn't identify a user. It was never intended to identify a user. It was intended to give you access to some resource like a Twitter timeline or like some specific API or something like that. But then people started misusing it for authentication. So what they would do is get like one of the resources that you could potentially get access to is effectively like a who am I resource. But the problem with that, it's subtle, like it's real subtle. But like the problem with that is that these tokens weren't bound to the third party. It was never designed to do that. So like I could like write a Twitter app, right? And have you, Darren, like log into my Twitter app and get an OAuth token for you. And then I could put that OAuth token in my Twitter client on my phone and masquerade as you on my phone, right? And so there are variants of that problem where the token's not bound to the client, and it just wasn't designed for that. So OpenID was federated authentication. OpenID was like, this is how you're supposed to log in to Twitter using your Google account, rather than give Google access to your Twitter timeline. And if you're having trouble following along, that's because everybody has trouble following along because it's super subtle. But then, yeah, OpenID Connect like adds an authentication, it like simultaneously solves the problem and makes it more confusing by adding this new identity token at the end of the OAuth flow. So at the end of the OAuth flow, you get your access token, right? That's meant for like authorization. You also get an identity token that's a signed JWT, JSON Web Token, a JOT, that is bound and does all of these other fancy like security cryptographic things to solve some of these problems with using an access token for identity. And to do that, IETF, in typical IETF fashion, went off and had to like develop the entire Jose framework with like JSON Web Tokens and JSON Web Signing and JSON Web Application or algorithms and encryption and 1,500 pages of spec so that they could put a base 64 encoded signed JSON object in like the last response of an OAuth flow. But hey, I guess it works now. There's a happy ending.
So I wonder if it's confusing what is what. How did people start misusing it?
Oh, people misused it immediately. It was almost encouraged. Like, I think even to this day, Twitter's API sort of encourages you to use OAuth 1.0, like, for authentication. And the thing that's infuriating about it, and like, is there's so much nuance because like the way that they tell you to do it is actually safe. It's not that like what they're telling you to do, like if you follow the letter of their instructions is wrong. It's that it's so easy to misuse, which is a big security problem, right? Like that's the sort of thing, these human factors are the sorts of things that like real security researchers who really care about building secure protocols think about. If you use it in like a very particular way, it's okay. But like as soon as you get outside of this like tiny little box, it's just like, yeah. The fact that we have to have this conversation is the problem. So people started misusing it immediately just by accident because to use it correctly, you have to be a cryptographic protocol expert to understand the nuance and subtlety of it.
That's what I was referring to when I said it's strange that it's so confusing and yet people misuse it. I mean, people misuse things that are very clear what they are. And then I cannot even imagine the situation in which 15 minutes later they wouldn't misuse something like that. I mean, to be honest, this probably tells something about my brain capacity. I got lost in the middle of what you were explaining. That's what happened.
I did too a little bit, if I'm honest. So it's not just you. Yeah.
There's a reason why machines actually implement the flows and not humans. So let's take this idea here for just a second. In the good old days, probably when you were maybe 5, and I was in my second programming job at that point, everything was in the data center. We all lived in a building. Going back to what Victor was talking about, we had the server down in the basement because that's where the best AC was. It was underground. Everybody was on the same network. We didn't care about authentication. We didn't care about encryption. We didn't care about anything because we were self-contained.
That does make certain sense, right? If you're within the same network and nobody can enter, really, then you can probably, and security people are going to freak out now, you can probably loosen the security requirements within the fortress in a way, right?
Yeah. Everyone's inside the fence. You don't let people you don't trust inside the fence. Everyone's, in the same friend group. Who cares? It's an approach. Everyone's trust posture is different. If you have a small number of things inside of the fence, it's quantified, you understand what's going on, yeah. But then CI/CD happened, and engineering on call happened, and microservices happened, and continuous deploy happened, and containers happened. Now you don't have 3 things inside the fence that are changing once every 18 months and being administered by one person.
So what you're saying really is that the solution is to forget about SaaS, forget about cloud, that everybody should go back to the office, start constructing that data center in a basement, get one massive database and WebLogic.
That's right. That's throw Java jars over the fence to the ops person in the basement. That's right. Yeah.
What's wrong with that?
I guess nothing, except that the world has seen how quickly you can innovate technologically. There are human reasons for, look, after Simple Geo, I went on and I was CTO of a company called Bettable. It was a platform for online gambling. And that's like the next step in the sort of logical progression of my journey to Smallstep and caring about security as it pertains to this stuff. Like people talk about technical reasons for microservices versus monoliths, right? And like the infrastructure costs, so like how much like AWS Lambda costs or whatever. It was never about that. It's about scaling the people side. It's about how do we get 1,000 engineers or 10,000 engineers to work productively together on one, effectively like what comes together as one system. It's not about technology really at all. It's about how you develop technology at scale quickly.
You have no idea how grateful I am for saying that, because I've been fighting people on that subject for a long time, kind of like, why microservice? Why monolith? What is the size of microservice and stuff like that? And I don't know, whatever 5 people can do, kind of, that's the right size. Now, if 5 people can create the biggest application in the world, I'm fine with that. I'm perfectly fine with what you call monolith if 5 people can manage it. And if you need 50, we have a problem.
And, that can be done too. There are technologies that to some extent support that. Like a lot of what microservices do is they force a level of hygiene in your component interactions. Like you can't cheat the way that you can in like a Python code base with like duck typing, where you can sort of like sneak in and hit like a private method or something that you're not supposed to, right? Like things have to be hygienic and loosely coupled. But yeah, there are other ways to do that. Sure. Yeah, there are other ways to do that, but nobody's really proven out any other way at scale.
I would say it's not that much about other ways. It's kind of, there is no other way that prevents humans from doing silly things. To me, that's the real kind of, that physical separation. You need to talk to my API. You cannot just kind of import a class and then start doing some nasty things that you shouldn't be doing. And I know that we all have architecture cookbooks that say that you shouldn't be doing that. If you can do it, you're going to do it. To me, that's the thing. The same thing with security.
Yeah, if you let yourself, you start going down the path of like, like, what if we designed a programming language that did this? And man, have I gone down that path? And, and like, yeah, in theory, it's possible. But like, we all live in the real world, and that go tell every programmer out there that they're going to have to like write all of their code in this one programming language. You're going to get more of a religious war than we already have around microservices if you try to do that. So,
well, all we need is Java as a monolith running inside Tomcat. That's it. That's all we need. That's all we need.
What about C#?
If you have to run on Windows, sure, I guess.
I actually loved C# back in the day when it appeared. I think it was brilliant. I mean, I preferred it over Java at that time.
Don't tell anybody I said this, but it is technically... Right, I haven't written Java in a while, but when I was writing Java, C# was objectively a better language. And I'm not a Microsoft or Windows person at all, but I'll comfortably say that. Come at me.
So we're talking about at scale. So let's go back to my little story. I had my app running in the basement. Everybody's good. Now time has marched along. And now we've got that app that's got to run in fill-in-the-blank hyperscalers, multiple hyperscalers, because some C-level person read a blog post somewhere saying that we can't trust a single hyperscaler.
We cannot depend on single hyperscaler, so we're not going to have one point of failure, we're going to have 3.
Well, and remember, they're getting that bill every month that is 3% more expensive. So they might be right.
I mean, that just coming out of the 4 walls, even out to a single hyperscaler, if you're used to not running everything secure inside, man, did you get a slap upside the face.
Yeah. Yep. Well, and rewinding to the history of agile CI/CD microservice cloud native containerized DevOps, Kanban, what else can I throw in there? A lot of it came out of startups, right? And here's like my 50,000 foot on it is startups don't care about security, and sort of like your 3 servers in the basement analogy, they shouldn't, because it doesn't rationally make sense to spend more on security than the value of the thing that you're securing. And if you're a nascent startup, you don't have much to protect. So it's much more important to have a methodology and technology stack that moves quickly, that you can iterate and develop quickly, than it is to have that thing be secured. You have 30 employees, 15 employees, 2 employees. You trust them. You sit next to them every day. So like their security story wasn't that bad, and it didn't need to be better until the startups started growing, and until other larger organizations saw the benefits, and people who the Fortune 100s were like, we want some of that too. We want to be able to move that fast and do those sorts of things. It wasn't until that started happening that people started thinking, wait a minute, how do we layer security and audit and compliance and good governance on top of all of this stuff?
But it's also, I feel, and you please correct me, that there are less and less excuses. Kind of the cost of being secure, I feel, is in a way dropping, even though relative to the scope and the size of what we're doing, of course. One server will always be cheaper to secure than 1,000, right? But the sheer effort that we had to do for the comparable workload in the past was much bigger.
I'd say so. Yeah. And you're absolutely right that the cost has come down significantly. There are fantastic tools that help manage CVEs and keep your supply chain secure. And, what Smallstep does, enable end-to-end encryption between all of these devices, workloads, people in your system.
My very limited, and I'm really a newbie at this area, understanding of end-to-end encryption is that you need to have 57 different points where you encrypt and encrypt again and encrypt again and encrypt again, right? Kind of traffic enters, load balancer gets encrypted before, and then decrypted and encrypted again, and enters your Kubernetes cluster, and it gets decrypted and then encrypted again. And am I completely wrong that we are encrypting and decrypting things all the time?
I think you're right. There are layers of encryption, but what cryptography is allowing us to do is build logical abstractions, sort of security layers, the same way we used to with physical hardware, right? So I don't think you shouldn't be encrypting and decrypting. What we preach and what we want is you have a client and you have a server, and the client server communication should be end-to-end encrypted. In other words, our approach is to use TLS, mutual TLS, and certificates, X509 certificates, primarily to power that. Now, where you're right is even when you do that, there are additional layers of cryptography that are likely happening. You might have, heck, AWS VPC, right? Even if you're not doing it, the clouds are. But cryptography is cheap now, and you're getting something out of that. AWS is encrypting your traffic at the VPC level for a different reason than you're encrypting your traffic at the client server level. That's okay. Well, we shouldn't be afraid of that. That's not a problem. That's not an anti-pattern. That's just two layers of the stack.
I get all the time questions. Hey, I understand that I should encrypt, and I'm greatly simplifying it now. Incoming traffic should be encrypted, but once it reaches my cluster or whatever it is, then kind of there is no strong reason or argument in favor of doing mutual encryption, MTLS, things like that. How true or untrue is that?
I think the evidence is that that's pretty untrue. Again, everyone's security model threat posture is different, but you're taking a risk by doing that. And I think they're quantifiable and known risks. So I suppose, again, it depends on the value of what you're trying to protect. It depends on the size of your organization. It depends on a lot of other governance and security things that you're doing. But I think it's hard to argue that that's a better security approach. I think the only argument is that doing it the pedantically right way, the way that I just suggested, is infeasible or cost prohibitive or too hard. And our mission as a company is to make that not be true. If that's not true, then you really are out of excuses. If it costs the same, if it's just as easy, then why wouldn't you? It clearly has a security benefit.
So from a Smallstep perspective, you're doing MTLS high level, and that's everywhere all the time. Is there ever a time where you would never encrypt from a Smallstep perspective?
there's no benefit to it. So I'd say no. I mean, I suppose where you can't, where it's not supported, you pragmatically have no choice. But where it's available, yeah, encrypt.
And that's the argument, right? Because now that it's simple, it used to not be simple. Number one, it used to not be simple. Number two, it used to be stinking dollar-wise expensive.
Right.
To pull off. And now a lot of this has either become open source. Smallstep has some open source components that are available. I do want to talk about those because I'm actually a little confused on it. Is it just at the point to where if people aren't doing it, number one, other than the reasons why it can't be done, you're running up against a 1967 mainframe that doesn't have the proper modules to actually do the encryption levels that you need, right? That is still a thing. But if you're running everything on the hyperscalers today, you've got no excuse.
That's right.
There's 2 open source projects associated with Smallstep. By the way, Smallstep is smallstep.com. Just plain and simple. There's 2. I can't figure out the difference between the 2 because one looks like a subset of the other. Not to be, I'm not trying to be a smart aleck here. I'm scratching my head because it looks like the CA one, technically called, was it Step CA? And the other is just called Step. People are listening today. They've never heard of Smallstep before, and they're wanting to try to do a hello world.
Yeah.
What are they doing?
Okay, so here's the stack. And the repositories are named poorly, right? Like our GitHub repo for Step CA is smallstep/certificates. The repo for Step is smallstep/CLI, but the 2 binaries that you'd be using are Step and Step-CA. Step-CA, in that certificates repository is an online certificate authority. It does X509 certificates, it does SSH certificates, and it's designed for the sorts of scenarios that we've been describing today. And that was the reason, that's the justification for its existence, is that there wasn't a modern tool chain for hyperscale, let's call it, certificate management that operates at the pace and scale and availability and reliability and scalability requirements of modern infrastructure. If you wanted to issue short-lived certificates to millions of services that renewed, every couple minutes or something like that just didn't exist. So that was the impetus for creating Step CA. And it's a cool piece of technology. It's widely deployed. It's deployed by Fortune 100s, publicly traded companies, governments. It's extensively used. It has a lot of capabilities around enrolling into certificate management, which is really helpful. So we support, you sort of alluded to web PKI certificates for your website being like free and easy. Well, a lot of that is because of the ACME protocol, ACME, that Let's Encrypt uses, and a few other certificate authorities now support. Well, Step CA supports ACME as well. So if you're using ACME for your web PKI, you can stand up Step CA and you can use it for your internal services, for your Nginx, for your Caddy or Trafic or whatever you're using. You can use CertBot, you can use ACME SH, like whatever standards compliant client you're using, you can use that to get search from Step CA. You can also use instance identity docs for your VMs. You can use short-lived single-use tokens. You can use an identity token for people, an OAuth OpenID Connect identity token to issue an X509 or an SSH certificate to a human. So there are a bunch of different, what we call provisioners, ways to get certificates, and then you can renew them and track the status of them. So that's Step CA. That's a certificate authority, really important core component. The other bit of kit that you reference is Step. That's the command line tool. That's a CLI. And Step CLI, one of the things it does is provides workflows, command line workflows for getting certificates from Step CA. So it makes it really easy to write a bash script or a Puppet or Chef or Ansible code to get certificates and manage them, keep them renewed, put them, have systemd units to rekey and renew stuff on an appropriate cadence. Step CLI has a bunch of other cryptography tooling in it, right? So it has like jot inspect functions and you can encrypt stuff with it. And you can think of it sort of like OpenSSL, but like a higher level of abstraction. Our goal was to make a tool that was more democratic, more accessible, not necessarily for cryptography experts only. Like OpenSSL is a great tool, but like you have to be an expert. Step CLI is designed to be easy to use and hard to misuse. And then on top of that, we have our commercial offering. And the commercial offering sort of takes everything I just described, puts it into a platform with workflows and abstractions that allow you to, instead of having to worry about like, what's the best way to provision and renew certificates for my Nginx on an EC2 instance, you can just tell us, I've got some EC2 instances and they run Nginx, and we'll model, the devices, workloads, and people, and design the PKI and give you collaboration and audit and dashboard reporting utilities on top of all of that. Does that help?
It helps, yes. I want to go back to your OAuth and OpenID days. I'm going to see if I can pull something out of your head. So we talked about the back history on those two. Where the heck did Acme come from? Was it because of Roadrunner and Wile E. Coyote? Is that where Acme?
Name?
Yeah, I mean, or is there a real name? Since you had history on other things, did you have history on Acme?
It stands for Automated Certificate Management Environment, and I don't know who came up with the name. I wasn't there for the Acme standardization. I've been around for some of the stuff, like some of the more recent stuff, but I don't know who came up with the name. I assume that absolutely it was a reference to Looney Tunes,
Well, certificate management is definitely Looney Tunes. Hopefully they're not going to come after me by saying that phrase out loud, but we give them credit. So anyway, Smallstep is at smallstep.com. Now, could people just take Step CA and Step and do everything? Not everything the commercial product does, but could they piece it together and feel the pain of piecing it together?
Yeah, sort of the same way that you could take Ori Hydra and rebuild Okta.
Right.
Right?
Okay, yeah. That's very, very reasonable.
Yeah.
Step CA does all the things, and Step is you didn't use this phrase, but I'm going to call it a more straightforward way to deal with OpenSSL. Because if you've never dealt with OpenSSL-S connect and put in a domain name, you haven't been living. I'll just put it that way. Ask me how I know. Well, Mike, anything else to say for today?
No, it's been fun.
Probably not what you were expecting.
Not entirely, but no regrets. Like, I'd do it again.
Thanks, Mike.
Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.